Good morning, everyone. And today, let me discuss the new concept. That means that exercise Bayes theorem we have completed. Now, random variables and distributions. Right. Next exercise 13.4. Right. Random variables. Write down and distributions. This entire 13.4 depends upon random variables itself. Distributions is in 13.5 exercise. Okay, random variables and distributions. Now, first of all, what is called a random variable? Random variable is a function which maps from S to R. X is said to be random variable which maps from S to R, means where S is sample space and R is called real number. Repeating, random variable is a function which maps from S to R, where S is sample space in the random experiment and R is said to be real number. That means the function, see here, it is a function. Now, the function whose domain is sample space and range is a real number is called a random variable, and it is represented with X. Random variable is denoted by capital X. Now listen, X has some values. That means the range of X is nothing but a real number. First of all, copy these 3 points, right? Head on. First, write down this point. The function whose domain is sample space, the function whose domain is sample space and range is a real number, and range is a real number is called a random variable. Is called a random variable. Second point, X, it is represented by X maps S to R. Yes, next one. Third point, random variable is denoted by capital letter X. Now, the side heading, write down the side heading, probability distribution. Probability distribution. Write down the side heading, probability distribution. See, what is called a probability distribution? If xi, small xi, is an element in the sample space having the probability p of x is equal to xi, then sum of this probability P of x is equal to xi should be equals to 1. This is said to be probability distribution. Repeating, probability distribution is nothing but the tabular column, right? Whose sum of probabilities is equals to 1. Where if I consider xi is an element in the sample space and probability of that xi is nothing but P of x is equal to xi, then sum of probabilities should be equals to 1. Okay, take down, I am giving you the notes. Side heading, probability distribution. Write down the notes for that. The set of ordered pairs. The set of ordered pairs, I am going to write on the board. The set of ordered pairs, right? Xi comma P of x is equal to xi is called probability distribution. Is called probability distribution. Right? Next one. Second point. Sigma P of x is equal to xi is equals to 1. That means sum of probabilities is equals to 1. Sum of probabilities is equals to 1. Yes. Next side heading it is mean. Write down the side heading mean. You know mean in your what it is in your 10th standard and your sequences and series first PU, right? The same thing. Let x maps S to R. Write down mean. It is represented by mu in bracket. Write down. Let x is a random variable from S to R, okay, with the range, what is the range here? x1 comma x1 comma x2 comma x3 and so on, xn, mean or expectation or expected value of random variable x is given by E of x, means expected value or mu, which is equals to sigma I is equals to sigma I is equal to 1 to n xi into P of x is equal to xi. Take down this one. Of course, I am going to tell you the shortcut for this one, and it is represented by x bar if probability distribution has been given to you, okay, you can find out the mean by using this formula. I am going to tell you the shortcut method to do, but suppose if he asks us define mean of a random variable for one more question, you want to write this, right? Let x maps S to R, okay, is a random variable which is also a function with the range x1, x2, x3 and so on xn. Mean or expected value. Mean is also called as expected value and it is represented by E of x, which is equal to mu, is given by this one. Take down. I hope you wrote it. Yes, after that, variance. Write down the side heading. This is mean. After that, write down the side heading, variance. The variance of capital X is denoted by sigma square is equals to sigma I is equal to 1 to n p of x is equal to xi minus mu or xi into xi minus mu whole square. I'm going to give you the shortcut method at the time of problems, so don't worry about it. Or you can also write like this: sigma square is equals to sigma I is equal to 1 to n xi square into p of x is equal to xi minus mu square. This is very easy. Don't worry that the formula seems to be very ugly, but the problems are very easy to do comparatively to the previous exercise. Very easy problems. You are going to get a table and he is going to ask you mean and variance. I am going to teach you that means shortcut method. So don't worry, and even it is applicable to PU also. But suppose if he asks us to write the variance, you should write this definition for 1 mark. Variance, okay. After that, standard deviation. Write down standard deviation. Write down the first point. Standard deviation of random variable capital X is equal to root of variance, which is equal to root of sigma square is equal to sigma. Next one. This is standard deviation and variance. Okay, next one. Write down the first problem. See, before going to do this, he is going to ask you one question like, which of the following are probability distributions? Okay, first of all, which of the following are probability distributions he is going to ask you. At that time, what to do? The first one. Okay, sum of two rules you should know whether it is a probability distribution or not. That means in 13.4, he is going to give you the questions like this. Which of the following are probability distributions? Right? That means the given problem is said to be probability distribution if and only if the probability, sum of probabilities is equals to 1. You should remember, sum of probabilities is equals to 1, the first rule. The second rule, it is probability of any event should lie between probability of capital A should lie between 0 and 1. You should not get above 1 or below 0. Means it should not be negative. If these two rules are known to you, then 13.4 is very easy to do, right? Now I am going to share problem number 1 in 13.4 exercise. Observe that one clearly, okay, on the screen. State which of the following are not the probability distributions of random variable. Give reasons for your answer. Observe the first table. It has been given like this, right? X, okay, it is random variable. X has values 0, 1, 2. It has been given, right? And P of X is probability of this X. It has been given as 0. I think 1 minute. 0.4. Okay, this is also 0.4 and this is 0.2, right? Now, which of the following are probability distributions, he asked you. Observe. First of all, what is the meaning of this question? If X is equal to 0, probability of that X value is equal to 0.4 means you auto solution P of X is equal to 0 value is equals to 0.4. Probability of X is equal to 1 value is equal to 0.4. Probability of X is equal to 2 value is equal to 0.2, right? Okay. Now, I have given you one formula called sum of probabilities. You just check sum of probabilities. 0.4 plus 0.4 plus 0.4. That means sum of probabilities is equals to 1. Right? Therefore, X is the P of it is. That means the given it is probability distribution. Given distribution is probability distribution. Okay, which are not, he has given you. This is probability distribution. Now, which are not probability distributions? Suppose sum of probabilities is not equal to 1. That is not probability distribution. And in the probabilities, if any one is negative, then it is not probability distribution. I am repeating. If we have done like this now, it means 0. Probability is 0.4. That means you should write like this. P of X is equal to 0 value is equal to 0.4. P of X is equal to 1 value is equal to 0.4. P of X is equal to 2 value is equal to 0.2. Right? That means probability of getting 0 is 0.4. Probability of getting 1 is 0.4. Probability of getting 2 is 0.2. Now, if you add these probabilities, you should not add this one, okay? This is range, okay? If you add these, right, that should be equals to 1. If it is not equal to 1, then it is not probability distribution. Suppose if probability in the given table, if probabilities are negative, then it is also not probability distribution. Okay? Why? Because probability should not be negative and it should not be greater than 1. It should always lie between 0 and 1. Okay? Copy this problem. It is probability distribution, you should write. This is probability distribution. Okay? Which are not probability distribution, he asked you. I am going to share the problems on the screen. Okay? Copy that one and write down which are not. Second one. I am going to share the second problem. Observe that second problem. X. X 0, 1, 2, 3, 4. Right? P of X 0.1, 0.5, 0.2 minus 0.1, 0.3. That means, observe what is the second explanation, second problem explanation. P of x is equal to 3 value is minus 0.1, which does not exist. See here, in the second problem, P of x is equal to 3 value, it has been given minus 0.1, is not possible. Why, sir? Why? Because probability of any event should lie between 0 and 1. So it is negative now, it is not possible. Therefore, given distribution is not probability distribution. Take down. Yes, see the third problem. You should write like that. Huh? See the third problem on the board. Y, P of y. Here he has given you y is equal to minus 1. It is possible. Why? Because the domain can be as a sample space, it is minus 1. But you should not get the probability value. You should not get the probability value negative. That means you should not get minus 0.6 like that. But observe. Sum of probabilities 0.6 plus 0.1 plus 0.2, that is not equals to 1. Alright. Therefore, the given distribution is not probability distribution. You should write. The given distribution is not probability distribution. I hope you understood that. Right? And that means you should write like that. The given P of x is equal to 1 minus 1 is 0.6. Okay. 0 value is given as 0.1, I think. It is 1 as 0.2. If I add these three, it is not equals to 1. Therefore, it is not probability distribution. You should write. Okay. Like this. Explanation should be like this. Right. And observe that next problem on the screen. Observe that next problem on the screen. P of x is equal to, you add 0.3, 0.2, 0.5. Okay. I hope it is more than 1. Write down the explanation for the fourth problem as sum of probabilities not equal to 1, the given distribution is not probability distribution. I hope you got this. And I am going to share the next problem, second main, on the board. Observe that one and how to do that problem. And first of all, what is the meaning of that problem? What is the meaning of that problem? An urn contains 5 red and 2 black balls. 2 balls are randomly drawn. Let capital X represent the number of black balls. What are the possible values of X? That means random variable. Is X is a random variable or not? Copy that one or take the screenshot of that one. Now, how to do that? Observe. Given red balls is equals to 5, black balls is equals to 2. I hope 2, right? Let me confirm. Yes, black balls are 2, right? Here, X represents black balls. Now, observe. 2 balls are drawn, right? 2 balls are drawn. Both may be black, right? BB. Both may be black, right? First one is black and second one is red. First one is red and second one may be black. Both may be red. That means both are black means 2. One is red and one is black means 1. Both are red means black is 0. That means X has values. X is equal to 0, 1, 2. Therefore, X is a random variable. Why? Because it is varying 0, 1, 2. I am repeating. This is the answer for the second problem. I am repeating this problem, right? Given number of red balls is equal to 5. Given number of black balls is equals to 2. X represent black balls given to you. X has value. That means, observe, if 2 balls are drawn, full stop. If 2 balls are drawn, if two balls are drawn, right, both may be black. I may get both black, right? First one may be black, second one may be red. First one may be red, second one may be black, or both may be red. Means I should see only X represents black balls now. So I should take the consideration of only black balls. So both are black means two are black. One red or one black means in these two only one may be black. And both are red means zero black. So X has values 0, 1, 2. Okay, X is a random variable. Copy this one and copy as it is. After that, I am sharing the third problem on the board. Write down the third problem. Write down the third problem after completion of second one. Copying second. See, observe the third one. Let x represent difference between the number of heads and the number of tails obtained when a coin is tossed 6 times, right? Now, very easy problem. You try to understand. If a coin is tossed 6 times, right? Observe. See here. Let x represent tossing or difference. It varies, na? Difference between number of heads and tails. Understood? Now, if see here, if a coin is tossed 6 times or 6 coins are tossed, you are going to get 6 results, right? 6 may be head and 0 tail. Okay, that means x has values or difference between 6 heads and 0 tail. Observe, 6 minus 0 is equals to 6. Sir, why you take modulus here? Because you can get 6 tail, you can get 6 tails and 0 head. Na? Obviously, the difference may be 6, right? And here, 5 heads you can get and 1 tail. The difference between them is equals to 4. You can get 4 heads and 2 tails. The difference between them is equals to 2, right? And 3 heads and 3 tails. The difference between them is equals to 0. Okay, so the answer should be, and of course, you are going to get 2 heads and 4 tails. Obviously, it is 4 minus 2 you are going to get. Why? Because I took modulus there now. So the answer for this one, it is 0, 2, okay, 4, 6. Okay, already I took modulus here. Observe that one carefully. I took modulus here. So the answer should be 0, 2, 4, 6. Repeating. X has values 0, 2, 4, 6. Now I am repeating. X represent difference between number of heads and tails. He has not given you respectively. So I took modulus here. 6 heads and 0 tail. I can get like this now. 6 are tails, 0 and 0 head. So you are going to get like this. And 5 head, 1 tail, 4. 4 head and 2 tail, 4 minus 2. 3 head and 3 minus 3, 0. Right? So you will try to understand that x has values. Therefore, it is varying. So x is a random variable. Copy this one. Tomorrow, I am going to do some more problems. Thank you and have a nice day.